Good evening, sir.
Good evening. Just a minute.
Yeah, okay, sir.
Yes, schools have come. Your mic is off.
No, sir, it hasn't.
How come?
Like they haven't corrected it yet.
It's machine, no?
No, sir. This one is CBS exam this week.
Oh, okay. That will take time. Fine. So what are they teaching now?
That thing started at a vector relativity concept.
Relative motion.
Yeah, in vectors.
Okay. So which problem they are studying?
I'll forward the portion, sir. Just give me a minute.
Okay. What are the next test?
Sensor.
Yeah. You can see the screen, right?
Yeah.
Oh, motion in straight line, motion in a plane. This is what NEET type, no? 45 into 4 or what? Your mic is off.
This is for 45 marks total.
No, 45 questions, right?
Yeah.
How many marks each one?
Each one 4 marks and minus 1 mark for each.
So 45 into 4 is how
Wrong
much?
one.
9,
Each wrong
180.
one.
Fine.
180.
Okay, change in motion applied constant as a change in velocity, relative velocity in two dimensions, rain number on numerical. So this is the last up to 8-7. 8-7 is today. Okay, but test is on next week, no? 13th. The mic is
13th
on.
only test, sir.
Yeah.
Yeah, 13th only test.
Okay, fine. So this you understood, rain umbrella, numerical.
Yes, sir.
So relative, here what is the basic thing? You have to find out in which direction you have to point the umbrella to get maximum protection. Is that right?
Yeah.
Just a minute. So what is your answer?
Yeah. 13th exam we have, I think.
No. See, the only thing you have to find out in this, the most important thing or the interesting thing to find out is, as I
Yeah.
told, in which direction you have to point the umbrella. Okay.
Okay.
Let us take the simplest case. What is the simplest case? Yes. Simplest case is this one.
Yeah.
What is this?
Raindrops
Raindrops. Okay.
falling down.
Falling down. Okay. What is the next complicated case?
At different angles.
Different.
Hitting it at different angles.
What is the third possibility? This one, two. Third one. You have to guess.
Third
Guess.
one is the other side hitting the umbrella at both the directions.
Not both the directions. The rain is in one direction only. Others will become more complicated. Either it's vertically down, simplest case. Now I think it's coming in. So the person is walking in this direction towards right. Okay. The rain is falling down. Then it's the simplest case. If it is falling, hitting from the front, second possibility. Third possibility is from behind. Okay. Will not go more than this. Now, another simplest case is the person is not moving, it is at rest. Okay, so when this velocity is 0, that is he is at rest, what should be the direction of the umbrella? Understood,
That's
no?
not
The
the umbrella. Yeah,
simplest
they
case,
have to.
the rain is falling vertically down. The person is not
Yeah.
moving. Okay, he's also dressed. Okay, so in that case, the umbrella should be simplest, vertical, just vertical. Correct?
Yeah.
To get the maximum this protection. The next complication is the person is moving towards right with some velocity. Okay, in that case, just guess how should the umbrella be pointed. There are only three possibilities. One is this way. Okay, another one is this way, bend backwards. Third one is straight. That is when the rain is vertical and the person is also not moving. Okay, so when it is moving forward, which of the three possibilities is the correct one? First, second, third.
Yes, sir.
Okay, so one way to understand this, the umbrella direction should be the direction of velocity of rain with respect to the man. It will be a vector. By definition is velocity of this whatever rain with the reference. Reference is the man. With respect to man, how the rain is coming down. All are vectors. Is this clear?
Yeah.
Okay, I just
Yes,
need the
sir.
direction. So just have to cap it. Capping will just give me the direction. Okay, so here in the second case, velocity of rain is vertically down. I'm not changing it. But the velocity of man is towards right. I have to take minus VRM, minus VM. Minus VM is towards left. I'm thinking in terms of adding of vectors. So VR minus VM is same as VR plus minus VM. Okay, so this is minus VM. I just have to reverse the direction of the man. So this is my sum VRM. So umbrella should be facing this vector. Correct?
Yeah.
Okay. So next possibility is uh, the person is moving towards left instead of right. Is moving towards left. Then in that case, if I fine, I just have to reverse the direction of the van. So it will be okay. It's exactly the same thing.
Yeah.
Uh, I just have to flip this paper. So it will be this one. Okay, that's trivial. Next, go to this one, second possibility. And the rain is coming at an angle. I'll take
Yeah.
this.
Yes, sir.
Wait. Take this one. Uh, you know, Perumbakam, this branch, they have this, your mic is off. There
Yeah.
is a
Yes, sir. Yes, sir.
whiteboard, no?
Yeah. They have
Not a smart board.
not like a smart board.
Okay. What about projector?
They don't have that too. Only in auditorium they have.
Okay. That is one thing I don't like because suppose you want to display some question, not everyone brings the book every day, no?
Yeah.
But
But
up
they
to 10th
don't have the
standard,
digital copies of the books as well.
no, up to 10th standard, they are using that smart board.
Yeah.
You know the reason?
Why, sir?
Because the students have to join Chaitanya for 11th standard, no?
Okay.
That's like advertisement. Okay, so now let the man be at rest. That's the simplest possibility, right? The man is here. Just a minute. Oh, the man is here, but he's not moving. In that case,
Yeah.
the umbrella should be pointed in the forward direction, just facing this vector. Okay, so that also you can figure out by VR minus VM. VM is 0, so just the direction of VR is the direction of the umbrella. Okay, he just has to face that VR direction. So it will be in the direction of the rain itself. Second possibility is the man is moving towards right. with some velocity Vm is moving right with the velocity Vm. Okay, in that case, what will be the direction of the umbrella?
Direction of the umbrella
Towards,
against that like
yeah,
facing
again.
towards the vector is.
So it is either this one or this one tilted backwards. Okay, so which one is the tilted towards right or towards left? Towards right. Okay, that you can figure out by VR minus VM, or also by common sense, because the rain is coming from the front side. No.
Yeah.
So VR is this angle, and SD minus VM. So it will be this way. So the umbrella should be like this. Correct? So it should be tilted this one. So this is not possible because VR is from right. It's hitting you from the face. Okay, the man is moving on the front side. Okay, so minus VM is towards left. So obviously the thumb
Yeah.
has to be towards left only. So he has to face the drain. So it will be tilted towards or in the forward direction. Correct?
Yeah. Yes, sir.
There is no other possibility. Unless I change the direction of VM. That change the direction of VM is just I will flip this page. Okay. That's a trivial thing. We don't do that. Okay. I mean, we will not discuss that. So I'll move to the third one. Rain is coming from behind. Actually, this is forward rain. This is backward. In essence, it's hitting you from the back. Okay. This is just falling straight on your head.
Sir, just a moment, sir. I have few questions out.
No, no, let me finish this last case.
Yeah, yes, sir.
Okay. And then we'll move to that.
Like,
So
yes, I'll
here,
forward you that question, sir.
yeah, I'll finish this one. Just wait.
Okay. Okay. Yes, sir.
This is the interesting part. So here the rain is coming this way from the back. Okay, the man is moving towards right, VM. So here the umbrella is towards tilted to left or right.
The guy, that guy is left or our left?
So we'll expect this to be the answer, right? So this possibility should be ruled out. Whether forward tilting is also possible, that we'll figure out now.
Okay.
It's VR. VR is like this, and minus VM is like this.
Yeah.
So in this case, the resultant is this one. So backward tilting is possible. Can I get this from the forward tilting? VR is fixed, say, in a particular case, if VM is increased, if the man is running too fast, then VM will be this big. Okay, then the other direction tilting is possible. Man, the velocity of man is very high or high, VM will be like this, minus VM. In that case, relative velocity will be like this. The umbrella should be in the forward direction. So this is also possible. This is an interesting case. Your mic is off.
Sorry.
So understood now the tilting on the forward side, even though rain is coming from behind, I'll point my umbrella towards the forward side if the man is running too fast. That I explained with this vector diagram. VR is fixed. Okay. VM, if it is small, it is only this much. So the tilting will be towards the right. Sorry, in the backward direction. This one, Vm is small. Okay, resultant is like this. So the umbrella is in the backward direction to face the ring. But if the velocity of man is too high, say up to this, then the relative velocity this way. So the umbrella will be tilted in the forward direction. So this is also possible when the velocity of man is high. It's counterintuitive, but it's possible. Okay. Shall I explain this intuitively? Yes?
Yeah.
Is it clear?
Yes, sir. Yes, sir.
See, if the man is too high, no, the raindrop here will go like this and it will hit the ground here. Okay. But since this velocity man is high, this guy who is here, when it is here at time t naught, the raindrop here is at t naught. When it reaches here at time t1, this guy, since it is high, the total distance is reached here. So it's as if when it's starting, the rain is on the forward side. So that's why the umbrella has to be faced like this to hit the forward, raining the droplets on the back. But suppose the man is moving slowly, then the raindrop here would have come and reached this ground at some time t1. By that time, this guy would have traveled this much distance. So it's as if when it's starting, the rain is behind him. So the umbrella should be pointed backwards. Okay.
Yes, sir.
So now tell me a question. Which question? Which question you want to discuss? The mic is off.
Sir. Yes, sir. Like
Ah,
the first, second, and third. That
okay.
first question I managed to solve. Second
Mhm.
question and third question doubtful.
Yeah, I'll just. Okay, we'll go to the second one first then. Or go to the first one. Which one you want? Mic is off.
Sir. Yes, sir. The first
Which?
one I completed. The second one.
Okay, the driver of a car moving towards a rocket launching. The speed of 6 meters observed that the rocket is moving at a speed of 10 meters per second. The upward speed of rocket as seen by the direction of it. Straightforward question. You have to velocity of the rocket as seen by the so VR my VRM, no, VR minus VM. Okay, the man is in the car, or you can call it VRC, or this one matter. Uh, just a small draw a small figure first of all.
Yeah. Okay.
Just
Draw this.
draw a small figure. Uh, it's at 90 degrees, no? So you can take velocity of the car or the man as I cap and velocity of the rocket as minus J cap. Okay. And just combine those two, VR minus VM. What have we learned? Understood, no? Got the answer?
Yes.
See, rocket is going up, no? So it should this J
Yeah.
cap. So velocity of rocket is upwards, and velocity of the car
Words.
is towards right. Let me. It is going the direction towards the rocket. Okay. Okay, so this is the velocity of the man. Okay, so we have to find velocity of the rocket with respect to the man. So it's VR minus VM. VR is 6 upwards, so 6 J cap. Okay, and then, sorry, 10. 10 J cap minus the velocity of the man. Let the right side be x-axis, positive x-axis, where is 6 I cap. Okay, so this you have to convert to this one as a magnitude. So it will be, so magnitude of this will be 10 square plus 6 square, square root 5. So it's 136. So greater than 12. What? Oh, just the upward speed, huh? Upward speed is going to be seen by the. Yeah. So he's not asking the magnitude of this one. The upward speed of the rocket, asking it's 10.
Sir, won't can't we take it as minus of minus?
No, it's towards right. Right is this plus I cap only. What's your x-axis?
Both are traveling perpendicular to one another.
That's okay, man. X-axis towards right. Why is this one? This is the positive x direction, no? That's not.
Yeah,
See, whether I'm traveling this way or this way, this always positive direction travel. All are I caps
yeah,
only. It's on the negative side of the x-axis, but does not mean it's negative. Direction is positive only. I cap. Same as stationary. Is stationary observer is same. Oh shit. I understood the question wrongly. So velocity of the rocket is not 10 now. Velocity of the rocket is the thing we have to find out. VRM is 10.
oh, okay,
This observed thing is 10 and it is at some direction. Okay. VR is in the direction of J cap. That is the actual thing is the ground. So 10 should be equal to, or 10 square should be equal to velocity of the rocket square plus 6 square. Okay,
yeah,
this
okay,
is simple. See, 3, 4, 5 is a right angle triangle. No, 3, 4, 5. Okay, magnify this in 2 times. It will be 6, 8, 10. So it's 10 and 6. So the other one is 8. 8 is the correct answer.
yeah. Then
No. So you remember this result. 3, 4, 5 is a right angle triangle.
minus 64 8 meter per second. Yes.
No. What I'm saying is you don't have to do that calculation. 3, 4, 5 is a right angle triangle. That you know, right?
Yeah,
So magnify that 2 times. It will be 6, 8, 10. Okay.
yeah,
So hypotenuse is 10. One side is 6. So the other side should be 8. Okay. You can save time.
yeah.
Next question. Wow. Again, the relative velocity is given relative to here towards south. The wind is blowing from
E-
east to west. What is the direction? Where with respect to earth? Air is flying with a velocity this much relative to air towards south. Okay. The relative velocity direction is also given. Okay. First, you have to understand the question properly. Then answer is you have to figure out whatever velocity they are mentioning, whether they are real velocity or relative velocity, and is the direction relative or real or with respect to ground. Get the answer. First of all, draw a figure.
Then a relative velocity. Sir, the kilometers per hour they are given can be converted into meter per second,
Yeah, that you can do.
or we can convert the 15 into kilometers per hour.
Okay, that you do in the end. Get this answers in meter per second. So it's better to convert to meter per second. No, options are in meter per second. No. So convert to meter per second. First, you have to figure out what they are given. Velocity of aeroplane. Huh. Okay, aeroplane will denote as P. P is aeroplane. So velocity of aeroplane P with respect to air is 800 kilometers per hour towards south. So the direction is south. Has got some direction which is south. Okay, this is relative velocity.
Yeah.
Wind, this velocity of air is blowing from east to west. So draw a small. East is always towards right. West is on the left side. North is up. South is down. So the wind is blowing from west to east. So this is the direction of the wind. Or here it's air. Wind and air are same. And the velocity is given. So velocity of air with respect to Earth. So this is velocity of plane vector minus velocity of the wind. So let me call this west to east as I cap. Okay, so towards north will be j cap, towards south will be minus j cap. Okay, I cap is west to east, so the velocity of the wind, which they have given us minus 15, it's along I cap. Okay, so in this direction here, which is south, is minus j cap. Okay, so this is 800. So VP is 15 I cap. I have to convert to units. So VP is 15 I cap minus 800 J cap, but this you have to convert 800 into meter per second will be less, no, less or more. 800 into, okay, convert to meters will be 1000, will be 3600.
5 by 18, which gives 2000 by 9.
2000,
2000 by 9.
9, 9 8 72, 5 8. So 800 into 5 by 18. That is 4K by 18, no? 8 5 of 40. So this is
Yeah,
2K by
2000 by 9.
2K by 9. So this square plus 15 square. 2K by 9 approximately. So say this is 10. So 2 into 1000. 2 into 500. So it's approximately 1000. And approximately 100. 1000, say 200. So approximately 200 square plus 15 square and then square root. So there's only one option greater than 200. You don't have to do the exact calculation.
Yeah.
You can save time.
Okay.
It's 200 square plus 75 square root. So it should be obviously more than 200. There's only one option. So check the answer.
Yeah.
Is it correct? Correct, no?
Yeah, it is correct. It is correct. The
Yeah,
answer is 222.7.
yeah. So to understand what they are given in the question, maybe they are given the relative velocity.
Okay.
Also, yeah, they are given the relative velocity. Then it become complicated. Same thing for
Yes,
here
sir.
also. Okay.
Yeah.
This one, which question?
This one, I think not that. Sir, this is the wrong one, sir.
Okay. Oh, biology. No, last one.
Yeah.
Here it
This
is.
is physics paper.
Question paper.
This one is like second week question paper, sir. Why
Yeah.
is this here?
Okay, maybe you send it previous. You send it today itself.
I did send today, sir.
No, no, hold on, hold on. I made a mistake. I've seen something else. This one. Oh, fourth one or
This one. Yeah, fourth one. Fourth one is okay. Seventh one, I need help.
seventh one.
Sorry, sixth one.
The particle is moving eastwards with velocity of 5. In 10 seconds, the velocity changes to 5 towards north. Trivial question. See, V at this instance, you have to see, right is usually towards the right. How do you remember that? Yes, I'm not. So, in a plane of paper, uh, usually the east is towards right, correct?
Yeah,
And north is up. How do you remember this one? Assume India map. Okay, West Bengal is here on the right side.
yeah,
On the left side,
yeah,
Mumbai is there, and Maharashtra is there. Okay, north side we have Kashmir. South is Tamil Nadu, Chennai. So it
yeah.
should match with the India map. Okay, this is not the only way to draw, but this is one of the way to draw. But that's enough for our problems. Okay, so with this thing, you can take I cap as east. Okay, and J cap is north. South will be minus J cap. West will be minus I cap. Is it clear?
Yes, sir.
So with this thing, so wind is blowing at a speed of north. Which question? 6, no, yeah. So 5 meters, but it's moving eastwards, right? So it is 5 I cap. Okay. And in 10 seconds, there is velocity at T2 or V2, we can say, is 5 J cap. Okay. So acceleration is final velocity, which is 5 J cap, minus initial velocity is 5 I cap. Okay. Divided by the time, which is 10 seconds. So it will be a vector, take the magnitude. No, here, vector, but take the magnitude, you should match with the first one, and the direction given in the second part of the option. Okay.
Okay, sir.
Now try it.
Yeah. 1 by root 2. I got 1 by root 2, sir.
Yeah, check the answer. I mean, check
It's
the option.
moving
Acceleration.
northwest. 1 by root 2 northwest.
What option they are given?
Let me check.